Here we'll do another example with inverses, but this time we'll start with a square root function. Our first step, as before, is to swap the x with the y and try to get the new y by itself. When we exchange x with y, we will now have x equals square root of 2y minus 4 on the inside. We will still keep the plus 1 on the outside. Now we'll try to get that y by itself. Our first move is that we'll have to move that plus 1, and so we'll subtract 1 from both sides. When we subtract that 1 on both sides, the left now becomes x minus 1, and the right will still have the square root. Now we'll have to remove that square root. In our previous video, we said that the inverse of a square root was a second power. So to remove that square root, we'll use the second power. It bears repeating that square root and second power are inverse functions. This means if we had 2y minus 4 inside the square root and then took a square, we would lose the square root and the square and have just 2y minus 4 remaining. So let's write that on our equation, and on the left we will now have x minus 1 to the second power. On the right, the square root and the square cancel out because they are inverses. This leaves us with 2y minus 4 on the right. Now we're still trying to get y by itself, so we're going to have to now move that minus 4 by adding 4 to both sides. If we add 4 to both sides, we'll have x minus 1 squared plus 4 on the outside is equal to 2y. We're not going to worry about simplifying that x minus 1 squared. We know that is a binomial squared, and that would use the FOIL method. However, we're not going to worry about simplifying for this problem because our only job is to get y by itself. Now, all we'll need to do to get y by itself is divide by 2. Once we divide by 2, here's how our inverse will look. We'll have y equals x minus 1 squared plus 4 divided by 2. That will be our new inverse function. Now that we know our new inverse function, let's try to find the domain and range of both the original and the inverse. Now that we have our function and its inverse, we'll try to find the domain and range. First, for our original function, we have 2x minus 4 inside of the square root, and we know that anything inside of a square root must be greater than or equal to 0. So we'll have 2x minus 4 greater than or equal to 0, and we'll try to solve that to get the domain. If we add 4 to both sides of that inequality, we'll have 2x is greater than or equal to 4. To get x by itself, we'll divide by 2, and we'll end up with x is greater than or equal to 4 divided by 2, or 2. Based on that, we'll draw a number line. Remembering, just as in the previous video, that greater than or equal to means we will be closed and we will go right from that position. So we'll make a mark on our number line with a 2, put a closed dot, and we'll shade to the right. Our solution set will go from 2 to infinity, and that will be our domain for our original function. To find the range, though, we can use a property of square roots. The smallest a square root can be is 0 because it's impossible for a square root to be negative. Since square roots must be either positive or 0, the smallest that this term under the root can be is 0. However, the numbers in a square root can give you any positive number up to infinity. So if our original function is y equals square root of 2x minus 4 plus 1, let's imagine if the square root term gave us 0. If the square root term came to 0, we would just have y equals 1. But we could be any positive number higher than 1. But if y is greater than or equal to 1, we can draw that on a vertical number line, and we can say that y must be 1 or higher. So we'll draw an upward green arrow to show that y is going toward positive infinity. In interval notation, we would say closed bracket 1, comma, infinity, and that would be our range for our original function. What this means is we don't have to find the domain or range of our inverse at all because we already have the domain. The domain of our original function becomes the range of the inverse, and the range of the original function becomes the domain of the inverse. Therefore, since our domain of the original function was 2 to infinity, the range of our inverse will be 2 to infinity. Since the range of our original function was 1 to infinity, the domain of our new inverse will be 1 to infinity. So now we have the domain and range of our inverse function as well as domain and range of our original function.